Your phone, laptop, smartwatch, headphones, and even your car may all connect without a physical cable. But not every wireless network works the same way. A wireless network allows devices to exchange data using electromagnetic signals instead of a physical network cable between the device and its point of connection. In a typical home, Wi-Fi devices communicate over radio waves with a wireless access point built into or connected to the home router. When a wireless device sends data, its wireless adapter transmits the information as a radio signal. The access point receives that signal and bridges the device into the rest of the network. From there, routers, switches, cables, and provider networks continue moving the traffic toward its destination. One common way to classify wireless networks is by coverage area. A wireless personal area network covers a very short distance. A wireless local area network covers a home, office, classroom, or building. A wireless metropolitan area network can connect locations across a larger community or city. A wireless wide area network supports communication across much larger regions. A wireless personal area network, or WPAN, connects devices within a very small area around a person. Bluetooth is a common example, connecting devices such as wireless headphones, keyboards, smartwatches, and smartphones. A wireless local area network, or WLAN, connects devices across a limited area such as a home, school, office, or building. Wi-Fi is the technology most people associate with a WLAN. Wireless clients join an access point, and the access point connects them to the local network and its available services. In the most common WLAN design, devices communicate through a wireless access point. This is called infrastructure mode. The access point coordinates wireless access, ensuring that multiple devices can share the medium efficiently while bridging them to the wired network. Alternatively, devices can communicate directly with each other without an access point. This is known as ad hoc mode or peer-to-peer communication. It's useful for temporary setups like quickly transferring a file between two laptops in the same room. Moving to larger scales, wireless metropolitan area networks, or WMANs, connect locations across a campus or community. Wireless wide area networks, or WWANs, provide even broader coverage, using cellular data networks or satellites to connect users across entire regions and countries. Mobile connectivity relies on a vast infrastructure of cellular towers and, in remote areas, orbiting satellites. These technologies allow us to stay connected while traveling or in locations where traditional cabling is impossible to install. Cellular networks are divided into geographic cells, each served by a base station. As you move, your device performs a handoff, seamlessly switching between towers to maintain your connection. Satellite networks extend this reach even further, relaying data from space to the most isolated parts of the globe. Wi-Fi typically operates on two main frequency bands, 2.4 GHz and 5 GHz. The 2.4 band travels farther and passes through walls more easily, but it's slower. The 5 GHz band offers much higher speeds, but has a shorter range and struggles to penetrate solid objects like concrete walls. Wireless signals face several physical limitations. Physical obstacles like thick walls or metal structures can reflect or absorb radio waves, weakening the signal. Additionally, other electronic devices can cause interference, leading to slower data rates or dropped connections. Because wireless signals travel through open air, security is a major priority. Anyone within range can potentially intercept the signal, which is why encryption is essential to protect your personal data from unauthorized access. Modern security protocols like WPA3 Encrypt the communication between your device and the access point. This ensures that even if someone intercepts your radio signals, the data remains scrambled and unreadable, keeping your browsing and private information safe. From personal Bluetooth devices to global satellite links, wireless networks are the invisible threads connecting our world. I'm Umar Lodi, and thank you for joining me for this Quantex cyber lesson. I'll see you in the next one as we continue exploring the basics of networking.